So this slide, we summarize what we can do using stored procedures. So you can see in some special situations, it is very useful. So here a few cases. So if you have this kind of situations, so you can think about it. So using stored procedures. All right. One situation is in your web application, there are several programming languages involved in one web application, usually for the distributed web application. So in that situation, then for some data related, so data intensive data processing work, using database access a lot. So then we need to think about create some stored procedures. So that's one. And another, reduce data transfer, the response time to improve the performance for some data processing. If you do not use the stored procedures, you may need to access the database many times, and the data transfer between two servers, web server, database server, a lot of communications, a lot of traffic. Yeah. So in that situation, you need to think about using stored procedures. Yeah. All right. So that another situation. This one, permission. Some tables, most of the programmers may not have the permission to access some of the tables, but to access those tables, so you only want to access information in the aggregate fashion. Aggregate, okay? Minimum, maximum, average, sum, count, those aggregate functions. So then create a stored procedure to access those special tables. So here, typically these three situations. So you need to, create stored procedures to solve your problems. All right, so that's the summary of that slide. Then the last slide, just the format of the stored procedures. Two. So I mentioned before, but here just show you the concrete forms. General form of declaring stored procedures. The first way, you use the SQL statement, create procedure, okay? The keyword, procedure. For this case, you have input, so this is your input. But you do not have output. You only do data processing. You do not have output. So this type, similar to our void function or methods. So no output, okay? Similar to our void type. No return. Output. So then you need to declare local variables. Okay? Then procedure body. So you use SQL statements to write the logic, data processing logic. That's the first type. Second type, This time you need, because you want to return output, return type. Sometimes you need to, your function need to return output data. So now you need to use the second form. Create function, you use the keyword function. So then the input and this one output. Okay, so then the remaining similar. Okay. Your SQL statements to write your data processing logic. All right, so these two. So if I can find a simple example, I can show you. All right, so here, give you the background knowledge, because for this class we do not have time to do, for all these concepts, important concepts, we do not have time to do many examples. So it is better to show you some concrete examples. So I try to find. So I try to find some examples. Then I use supplementary videos to show you. So to give you some concrete impressions. All right, so we finish part D, module 2. Then let's move to module 3 about SQL basics. So for the SQL, before we start working on our SQL queries, so we need to learn some basic concepts related to SQL. All right, so let's understand SQL structure. 8.1, database schema concept. When we design a database, we need to use SQL statements to define several database constructs. So let's look at the schema concept. All right. So what's the schema? The meaning. Description of a database. The schema. The meaning of schema. So in history, there was the original meaning of schema, but our current meaning, description, how do you describe your database? How do you use a sequence of SQL statements to define the constructs in your database? That's the schema. Okay? Yeah. And the database schema only contain the definition of the constructs of your databases. It does not contain the data part. Okay? Yeah. The data. Yeah, because your database, you need to include the data, business data part. That part does not belong to the schema, that concept. Only the metadata part. Yeah, we talk about the metadata concept. Yeah. Only the metadata part belong to the database schema. Okay, yeah, all right. Specified during the database design. Yeah. When you have a database design in your mind, you need to implement. Okay, yeah. So you need to, implement your design ideas in a DBMS. How do you implement it? So you use a sequence of SQL statements to implement your design ideas. All right. Not expected to change frequently. So regarding this property, actually we need to look at this thing in two parts. Yeah. In two parts. Yeah. At an early stage, yeah, At early stage of database design, we need to change our database structure frequently. But at a later stage, it becomes more and more stable. At early stage, because we do not have a clear idea what should we do in the database design, right? At the beginning. But later stage, the database becomes more and more stable. Then we do not change frequently. So early stage, you need to prepare, change a lot of things frequently. So this part, the early stage, usually, it's very common, especially your database relatively large. So it's not a simple database. For a typical real world, big business application, so you cannot, because the database design is quite complicated. You cannot get a good design immediately, right? It takes long time evolving, and finally you have a excellent design. But at the beginning, it's hard to get that. Okay, early stage, usually change frequently. Okay, most of the time change frequently. But late stage, it becomes more stable. Especially after a long time evolving. Okay, evolving, better and better. So then the structure is very stable. Even when after the structure becomes very stable, if your business requirements change, then you need to change business requirements. Because you may need to add in new features, new functionalities in your web applications. Then, to support the new features, you need to add new tables, new data to support new features. So usually, whenever you need to add a new feature, you need to add new tables and the data. All right. Schema construct. What's inside schema? The construct inside schema construct. All right. Entity. So here, when you do, your schema usually contains many tables. The definition of a set of tables. Then, here let's look at your tables. All right. One type of table called entity table. Entity type table. Entity. You describe object. So what's the entity? You need to describe certain objects. For example, student is an entity. Okay? Student. You want to describe a business object, student. Employee. Employee is an entity, object. You need to describe employee. Okay? Here you can get an idea. A typical entity object you want to describe using a table. The table type is the entity type table. Okay? So many business objects you need to describe in the business world. Math problem, for example, another entity. Okay? The course, I want to describe a course. Transcript, I want to describe transcript, and so on. Okay? You can see most of the tables are entity tables. Most. But there are a small portion of tables, not entity tables, not entity type, not of entity type. So we will see that. All right. So the entity type tables you use to represent real world object, such as employee. Yeah. So, concrete, real world object. Yeah. But you have a different type of business relation you want to represent other than entity objects. Yeah. 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 Attribute concept inside a table. Yeah. Attribute. Yeah. That concept. So it's a column or a field inside a table. We call it attribute. Okay. Attribute, that's the formal name. Yeah. Remember? Yeah. So many times the same concept, we have multiple different names. Some names, formal names. Formal names in the relational database model. Yeah. Relational DB model. Yeah. So this attribute is used in that relational DB model. Okay. All right. But in the business world, usually we do not use the formal names. Okay. In the business world, for the attribute concept, we use column, or we use field. That's the business. The names we use in business world. Yeah. This attribute formal name usually people use in the academia environment. Yeah, because relational model originally it's an academic project. In that academic project, people use their formal names. All right, so this attribute concept. Yeah, but many times you see the attribute, this word. Yeah. All right, represents some property of interest on an entity, such as employee's name, age, salary, birth date, and so on. Sex, yeah, many attributes, yeah. All columns, fields. All right, that's the attribute concept. Relation, yeah, relation concept. Yeah. So this is also formal name in that relational DB model, refers to table. One relation corresponds to one table. Yeah, just a table. Okay. Yeah. All right. Yeah, but yeah. So here, this entity, but there is another type. Okay. Other than entity type of tables, there is another type. Yeah. The next slide we can talk about. Those two types together. Yeah. Table types. So when you design tables, typically you have two different table types. The first one, entity type. Yeah. All right, entity type. Yeah. Describe an object in the minute world. Yeah. This one easy to understand. But the second one, not as common as the first type. Yeah. So usually the number of such tables relatively small, but also important. Sometimes you need to use the second type. So what's that type? It's called a relationship type. Relationship type. Different from entity type. Relationship type. Okay? Yeah. So what's the relationship type? Yeah, from this name you can see about relationship between two objects. Relational database. Okay? Two tables are correlated. right? Yeah. Relationship type. Yeah. So let me describe the second type. Yeah. A relationship among two or more entities represents an association among the entities. So here, because we want to represent the business world well, in business world there is concept. That's the relationship between two business objects. How do you address that? Right? So here, let me give you an example. Relationship example. Example about relationship between two business objects. One example. So here, let me use the math question bank. I mentioned that. Okay. So let's think about it. We want to build a business application doing the math question bank. Okay. We have large number of math questions. So the instructors can use those math questions to make exercise sets or homework assignments or tests, using the questions from the question bank. So that business application. Okay. So here we consider the math question bank application. Okay. All right. Then, what kind of relationship table we may need? So think about it. When we have large number of math questions, do we want to assign them to different categories? So we have many math questions. And we want to organize a large number of math questions into different categories. All right, so here you can see question is an entity, right? Question table, it's an entity table, okay? And we need another table, category table. Category table, another entity, right? Category, you can have the algebra, geometry, trigonometry, right? And the number theory, calculus, right? Many different categories. So you want to allocate your math questions into different categories. Then, how do you represent relationship between math questions and the categories? You need to create a mapping, right? So one math question, so here, question. So let me use the, these symbols represent individual questions and individual categories. Okay? So each question, do you want to assign to appropriate categories, right? And also one question, it is possible one question belongs to different categories, also possible, right? One question could belong to multiple categories. Because the knowledge you use to solve that particular questions, you may need to use knowledge from algebra, from geometry, from number theory, from calculus, right? You need to use a lot of knowledge, right? So you may like to map, associate that question to multiple categories. And each category, you may have many you may have many questions, right? Yeah. So this kind of mapping, relationship mapping, we call the M-to-M mapping. Okay, M, multiple to N. Okay, M. Yeah. So the left-hand side, multiple questions may map to each category. Yeah, so that's one direction. The second direction, one question you may map to multiple categories. Okay, yeah. Two directions, and okay. Yeah. One connect to multiple. Yeah. So people call it M-to-M relationship. All right. So this kind of mapping, you need to use a table to store the association. Yeah. Association. This kind of association. Yeah, people use the word association or mapping. They sometimes using mapping, association. Yeah. So the table to store the data, mapping data. So that's the relationship type. It's different from the entity type. Yeah. Yeah. So typically you need to represent these two types of tables in a business application. All right. That's this concept. Yeah. Example, yeah. Oh yeah. In our this example, another example. This is in our later we will have a company database. In our company database, there is a table called works on. Yeah. From this name, works dash on. Yeah. From the name, you can realize it should be a relationship type table. Yeah. Because it's about relationship between two business objects. One business object is employee. Okay, one employee works on multiple projects, right? Yeah, yeah. One employee can work on several projects. Okay, each project usually there are several employees work on that object. So this is M-to-M. Yeah. So this relationship also M-to-M. Okay. Other than this one, M-to-M, so one-to-M, one-to-one. Yeah. So you can see how many different mapping types. Yeah. One is one-to-one, right? Yeah. One type. One-to-N. Yeah. One-to-N is also possible, right? Yeah. One-to-N. One-to-N. M-to-1 also possible, right? Yeah. So there are 4 different mapping types. M-to-1. So when you design your tables, you need to be aware of all these types. Yeah. The reason is because there are some graphical design tools. Yeah. If in future if you need to do the database design in your job, so usually you rely on some visual tools, drawing diagrams. Okay, so in those visual tools, you can select 1-to-M, M-to-1 with these 4 types. So because you want to communicate with other team players, right? Other team players discuss about the structure of the database design. Okay, so you use the graphical diagrams tool to show your team, other team members. Okay, yeah. Like yeah. All right. A relationship between So I use this example. Yeah. So here we have, these two examples, so you can understand the meaning. So what type of tables, so you can quickly understand. All right. Allow M to M mapping. It's quite common. So this kind of mapping quite common. All right. History of schema, because this concept also evolved. The early version of schema, the meaning is different. The meaning, actually, at that time, the structure of the databases quite different from the current, the way to organize the data in the DBMS, quite different. Let's look at the early version of SQL. Did not include the concept of relational database schema. Actually, at that time, actually the structure is not very friendly. So if we look at in the business applications, the structure is not very friendly. So why is that? Because this property, all tables were considered part of the same schema. All right, suppose in your DBMS, all right, because suppose this block represent DBMS. So you need to maintain several databases, right? Because you use this DBMS to manage several databases for several business applications. Okay? But early time, people, when they designed the DBMS, they use the tables, but they put all tables from different databases together at the same place. No separation. So look at this, the meaning. All tables, so here all tables from different databases. Were put together at the same place. So that, that big block was treated as one big schema. Okay? If you really want to use that schema concept, everything, all the tables from different databases belong to the same schema. Very messy, very messy. So that's the early time, tables mixed. So how about, so here, T1, T2, T3, all right? So because you need to maintain Tn, all right? So then T1 probably from DB1, okay? T2 from DB3, right? T3 from DB1 again, and so on, okay? Here DB5, okay? So, and these tables are not separated, okay? They are not separated. So that's the early time structure. Okay. So later, the reason actually pretty simple, because at that time the business application not very complicated, very simple. Okay. So even if the tables were not separated, still in this messy way, still DBMS can provide fine services, all right? But when the business applications become more and more complicated, then this messy way, won't be good anymore. So then the schema concept evolved to separate the tables for different databases. All right. Starting with SQL version 2. Yeah. Now, those researchers, so this research project, okay, academic research project. Yeah. So they changed the structure to organize the data. Yeah. So group together tables and other constructs. Other than tables, you have, domains, you have constraints, you have other constructs, okay, that belong to the same database application under the same schema. Yeah. Then, because in order to manage complex business applications, yeah, so you don't want to, mess up different tables from different databases. So you want to separate them, okay? Yeah. Yeah. So this one, that's the SQL 1 version. This one is the SQL 2 version, okay? SQL 2 version, DBMS. Then, each database, let's say DB1, then there is one block, okay? Yeah. T1, T2, T3, okay? Yeah. And then DB2, another block, okay? Yeah. Different tables, T4, and so on, okay? Yeah. And DB X, okay? Yeah. So the SQL 2 use this kind of structure, separation. With this structure, then the schema concept evolved to schema 1, okay? Schema 2. So each schema corresponds to one database, okay? Yeah. So that's the current meaning, schema X, and so on, okay? Yeah. All right. So the next time, so when you see the word, because people talk about database schema all the time. If people talk about database schema, so you know that's the definition of your database. Okay? All the SQL commands you use to define your whole database, excluding the database. Okay? Excluding the business data part. When people talk about the schema, people exclude the business data part. Okay, separate. Okay. Yeah. So because people may ask you, send me your business, your database schema. It does not include the data part. Okay. Yeah. Yeah. So you know the meaning. Yeah. All right. 8.2, database languages. So here we look at the background knowledge about the academic model, relational database, that model. Right? That's the information, because it was created from an academic project. Yeah, so the database languages, there are several types of database languages. Yeah. And currently we only know one, right? SQL. The current database language, you know, only one, SQL. Okay, yeah. But in the relational database model, yeah, there are several special languages used for different purposes. So here, just give you the background information. When you use them, so you may not use them much. Okay, just know those languages. All right, the first type, so those the creator, the model creator, those researchers. The one language called data definition language, DDL, initial, okay? DDL, data definition language, based on the functionality. So it characterize one language is needed to describe the definition, data definition. So that part of the language, so they give a name called DDL language. Right, so that's one. Define schema. The SQL statements define schema. Yeah, DDL. But another part of the language into use in this relational database model called the view definition language. You want to view it, okay? Yeah. So you want to see the definition, the structure, view language. So VDL language. Okay, yeah, all right. Specify user's view. Yeah. How to present the data in a specific view. Yeah. Right? Yeah. So you should have appropriate language to present your data in different views. So some language is needed. Okay? Yeah. Another type of language is data manipulation language, DML. You need to manipulate data, right? Yeah. So change here, there, do manipulation. Okay. Yeah. Yeah. So data manipulation, DML, third type. Okay. Yeah. All right. So it includes retrieval, insertion, deletion, modification of data. Yeah. So those researchers in their model design, yeah, so they want to build a relational database model. Yeah. So they put the technical specifications, implement all these functionalities, the part of the database languages. All right. Yeah, but although so many different types of database languages, but later we know SQL can do all those things. So SQL is a comprehensive, integrated language. Yeah. SQL contains, so all these things putting together, okay, SQL can do all of them, okay? Yeah. So that's the reason, although there are so many different names, but we just use one SQL, that's enough, okay? Yeah. 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 So for most people, they only know SQL, okay? So they do not need to use, talk about DDL, VDL, DML. Yeah. But sometimes when you read the database articles, you may see, this kind of names. Sometimes you may see names, so you know the meaning. Yeah. But don't worry, SQL can do all of them. Okay? Yeah. So you just use SQL. That's enough. Okay? Yeah. All right. So it's a combination of DDL, VDL, and a DML. Okay? Everything needed, all inside SQL. Right? Yeah. All right. Statements for constraint, specification, schema, evolution. Yeah. SQL, you can do everything you need related to the database. All right. 8.3, properties of SQL. First, it is a standard language for commercial relational DBMS, industry standard. So here we emphasize the standard. Okay? So all the DBMSs used in the business world must adopt this industry standard, SQL. That's first property. Okay? All right. But later, so we know, so there is something different we need to be aware of. So it's a comprehensive database language to do everything we need about a database. Both DDL, VDL, and also VDL, right? Including the VDL. Yeah, but the VDL, so here it does not mention the VDL. Yeah. View, right? Yeah, view. How do you view the data? View, we use the retrieval statement. We can see the data, right? Select, retrieve. Retrieve statements, that's part of the DML, right? Manipulation. Yeah. Actually, the name is not that important. Just some names. All right. It has facilities for defining views on the database, specifying security and authorization. Yeah. It's a lot of things. Security, privileges, right? Grant privileges. Now, the SQL statements, when used, you can, in order to consider the security issue, so different tables, you grant permissions to different types of users. The users with different roles, they can get permissions for different tables. So the SQL has that control. Authorization, so then people, in order to access certain tables, they need to pass the authorization step. If that particular user has the privilege to access certain tables, do authorization, checking, okay? Check the permission. All right, information. Defining integrity constraints. So we look at data integrity before. Several simple data integrity things. Okay, data type, the uniqueness, right? So integrity. All right. Specifying transaction controls. Transaction concept and transaction controls. All right. Rules for embedding SQL statement into general purpose programming language. So we as programmers, we need to write application programs. So that's the general purpose programming language. So Java, PHP, C#, and some other programming languages. Okay, Python, you want to access DBMs, you can also do that. Okay, so different programming languages, but to run the SQL commands, so in those programming languages, you need to embed. So What do you mean embed? What do you mean embed? Okay. Yeah. So in those languages, yeah. Yeah. So usually they are object-oriented programming language, right? Yeah. So object. So you create some programming object. Okay. Then you call some method. Okay. Object or method. Then you embed SQL commands. Okay. Or the double quotes. Right. Double quotes. That's the SQL statement. Double quotes. Yeah. As the input. Yeah. So your SQL commands is passed to those methods as the input parameters. So then you run, execute so that method. So that method has the capability to send the SQL commands to DBMS. Okay? Send to DBMS. So the DBMS, after the DBMS receives the SQL command, it needs to do the compilation, right? Compile. Yeah. The SQL command must be converted to the machine instruction. Yeah. Machine code. Yeah. So then it can run faster, right? Yeah. That's the meaning of embedding. So what do you mean? Yeah. Rules for embedding. Yeah. So your DBMS need to specify the rules. How to do the communication. How to send SQL commands. Okay. So your DBMS need to provide those rules. Then, so those programming languages, they need to follow your rules. In order to do the communication, those programming language, they need to follow the rules for a particular DBMS. So you can do the communication. All right. Structure of SQL. Core specification. Yeah. So the SQL contains two parts. The first part, the core part. Core specification. That's the industry standard. So when we talk about the standard, we mean this core part. Okay? Yeah. Supposed to be implemented by all RDBMS vendors. Supposed to. It's possible some DBMS vendors do not implement completely. That's possible. Yeah. So then there is a risk, right? Yeah. If you do not implement 100% the core specification, so there is some risk in your products. Yeah. So when the customers use your products, so they may get a problem. Okay? Yeah. Yeah. Specialized extensions, then this part, not part of the standard. Yeah. So this part, yeah. Optional modules, yeah. Not in the standard. Industry, so we talk about industry standard. So this is not in the industry standard. Okay? Yeah. So different DBMS products, they have different extension part. Yeah. So I talk about. Yeah. So here I mentioned some examples before. Okay. So for MySQL, for example, MySQL, this DBMS. I give you example. One example is this limit keyword. Limit keyword. Yeah. So that's the extension part. MySQL has this special feature, but other DBMS may not have it. So that's one. Another, auto increment, primary key. Auto increment. when we declare a primary key, we want to have this auto increment type primary key. This is also in MySQL, it's the extension part. Other DBMS may not have this feature. Even if they have a similar feature, usually they like to use a different name. Yeah. So they intentionally, yeah, because, you know, yeah. So they don't want to have the same name as a different DBMS, because that may cause some problem, right? The conflict, you know, business. Yeah. People may, you know, that vendor may sue your product. Okay, you know, you copy their features, right? Yeah. So that may not be a good thing. So people try to avoid different vendors, even for the similar features. They try to use different names. They intentionally want to use different names. Okay, because it's not a standard. So they have freedom to choose, you know, how to implement. All right. The consequence, yes, for us, we are programmers. Then we need to do more work. Yeah. Especially when you switch from one DBMS to another DBS, then you need to do quite a large amount of work you need to do to convert. When you do, you know, SQL query conversion, if the standard part, then you do not need to do any conversion. Okay, but for the extension part, then you need to spend a lot of time. You need to study the document, you know, study the examples, you know, try to understand the logic. So then you implement, you use different ways to implement the same feature. So that's a lot of work. And then you need to do experiments to see how well it performs. Yeah, but that's, you know, what it is in the business world. All right. So in application programs, when you change a DBMS, although, yeah, so sometimes you need to change, but, you know, most of the time they do not change. Yeah. But suppose, assume if you need to change, then you need to prepare to do large amount of conversion work. Yeah. Change your SQL statements. Yeah. Mainly with respect to the extension part. Yeah. The reason to do the change, because the statement may have a lot of features in that extension part. Yeah. All right. Then, yeah, the last slide of this part A. Yeah. So I think we can finish part A today. We have 10 minutes. Yeah. Yeah. SQL terms. Yeah. Terms we use. Yeah. Yeah. So when we, you know, describe the table structure. Yeah. All right. Relational model. Yeah, I mentioned this relational model a few times. Yeah. Yeah. Academic project. Yeah. This relational model, you know, comes from some academic project. Yeah. So it's different from the business version. Academic is very abstract. When this project is used in the business world, a lot of things may be changed. Yeah. Because the business world, the situations usually different from academia, right? Academia, people use logic. People use logic to build that model. Yeah. But when you move to the business world, the environment could be different from the academia, right? Yeah. So then, some concepts could change. Not many, not too many, some concepts could change. Most concepts do not change, but some concepts, the meaning could change. Later we will see. A very small number. All right. So here, this table, this chart, just give you the different names we use in, so the first row, that's the business row. So that's the terminology we use in the business world. This second one, academia. Okay. Okay. Yeah. People use in academia, the different environments. Yeah. So in business world, we call table. Okay. That we design tables, a sequence of tables. Yeah. Yeah. But in that relational model, yeah, so people call relation. Relation. But in our business world, if you use relation, that's weird. Right? So people do not feel, comfortable if you refer tables as relations. Okay, too abstract. So you want to use tables, you want to use standard. Everybody can understand. So then in a table, each row by row, okay? Yeah. So then in the relational model, people call tuple, okay? Or tuple, okay? Tuple or tuple, yeah. Because in math, there is a concept, the tuple concept. So what's the tuple concept, okay? So it's a group of data items. So usually you group several data items as one object. So let's say A1, A2, A3, okay, AN. So you group them in this order. Order is important. In this tuple concept, order is important. You cannot change the order. If you change the order, then the tuple value changes. Okay, you get a different tuple. Okay, that concept. In math, we use this concept. So this concept comes from math. All right. Yeah, in business world, a row you have multiple fields, right? You have multiple fields in one row of data, and the order is important. You cannot change the order. You have to follow that particular order for one row. Column, column, value, each column, in a row, there is a particular value. Column by column, those values. Then in the relational model, we call attribute. All right, so here just the terminology. Then the tuple, the meaning of tuple, an ordered list of elements. Property, ordered list of elements. Order is important. And because when we organize our data with using different concepts, sometimes order is important. Sometimes order is not important. So in this concept, tuple or row, this concept, order is important. Later, another place, order is not important, because when you talk about table, a typical table, you may have multiple rows, right? So let's think about it. So suppose this is one table. Okay. One table. In one table, you have multiple rows. R1, row 1, row 2, row 3, and so on. Okay? All right. Then, there is order issue, right? The order is, can you change the order of these R? Okay? Yeah? So, you can do swap operation is swap some of the rows. You change the order. Okay? Inside one table, the order is not important. In one table, yeah. So you can change the order. So the order in this table concept, the order for the rows, okay? Order, yeah, let me write a little more so you do not get confused. Order for the rows, not for the columns. For the columns is important, okay? For the rows is not important. Yeah. What's the meaning here? If you change the order, yeah, the row content is the same. Each row, you do not change the row content, okay? Yeah, you keep the same row content, but you change the order of the rows, all right? In one table. Then we get the same table, okay? If you change the order of the rows, you get the same table. Yeah. So we do not say your table is different. Yeah. So if you change the order of the rows, we still treat you have the same table. You do not have a different table. Okay? Yeah. Yeah. From these two examples, you can compare the difference. Sometimes the order matters, sometimes the order does not matter. Okay? Yeah. You need to look at what concept you are talking about, right? Yeah. Yeah. So, yeah. Pay attention to the details like this. Sometimes the order is not important, sometimes it's important. Yeah. Yeah. All right. Yeah. Yeah. So, yeah, different from a set and unordered. Yeah, because as I mentioned, this tuple is a concept from math. Okay, so it's an original, it comes from math. Some concepts, in computer science, so they are borrowed from math. Another concept from math, set concept, also from math. In math, there is a set theory. It's set theory. So a set in math has some specific meaning. Yeah. But the set concept in math, it's an unordered list of elements. In a set, if you change the order of the elements in a set, it doesn't matter. Okay? You do not change the content of the set. If you only change the order, yeah, you get the same set. Yeah. So the set concept and the tuple concept, they are different. Okay, they are different math concepts. Because they have different properties. They have different properties. Okay. Yeah. Yeah. Today I do not have much time. Yeah, I run out of time. So let me stop right here. But we finish this slide. Okay, and we finish part A. Yeah. So next time we will go to part B. Yeah. So when we learn more and more properties, yeah, so we get ready so we can do the queries. Okay. Yeah. So we will quickly move to SQL queries. Yeah. All right. So that's it. Yeah.